Welcome back to this most recent video, guys, video 2.11. We're going to be looking at ratios, rates, and the unitary method. So recall that we've used the unitary method before to solve percentage and fractions problems. And this method was, firstly, to reduce the amount to a single unit, and then we secondly expand the single unit to the quantity you require. So remember, say if we had 65% of something was X amount of dollars, you would divide both by 65 to get 1% is such and such dollars, then you would multiply, say, by 80 to get what the 80% was of the original quantity. Now, this method also works for solving ratio and rate problems, and we're also going to look at converting units and rates as well in this video. So really just two examples for this. We're just sort of building on using stuff we've already been looking at, and especially showing you the unitary method in action. Right, converting units. An example for you. Escape velocity, which is the speed necessary to leave Earth, is 11,200 meters per second. Convert this rate to kilometers an hour. So we're going to need to go from meters per second to kilometers per hour. Now, this is an interesting way of doing things. You need to use a little bit of back reasoning to get this one figured out, but the way we're going to go with this is that we have 11,200 meters per 1 second. Okay, and what we're going to do is we're going to convert this meters to, we're going to go from meters to kilometers first. Okay, now there are 1,000 meters in a kilometer, so what we need to do is that we are going to divide this quantity by 1,000 to get 11.2 kilometers per 1 second. Okay, now this, we have to go from kilometers per second to now kilometers per hour. So a way to jump there from that is go to per minute, from seconds to per minute, and from per minute to per hour. So we're now going to go from seconds to minutes. There are 60 seconds in a minute, but instead of dividing like we did here, because there's 1,000 meters in a kilometer, because the seconds is the per part, the time is the per part of the rate, the dividing part, we actually multiply. So there are 60 seconds in a minute, so we have to multiply both sides by 60. Okay, and that gets us, so this is sort of using that unitary method. We've got the units that we're wanting, kilometers and per second, and we're going to go up to, we've reduced down to 1 second, and now we're going to expand up into what we need. So 11.2 times 60 is 672. Kilometers per 1 minute. And then to get from minutes to hours, we simply multiply by 60 and multiply by 60, and that gets us 40,320 kilometers per hour. Okay, so that's the speed that you need to go to leave Earth's gravitational pull, which is pretty fast. So yeah, a little bit of a long process there, And there is some extra stuff that we might look at in class called dimensional analysis, which will help you to be able to do these rate conversions really easily. But you can sort of work your way through it using logic as well. Right. Okay, so this is a typical rates problem. We're not converting a rate. We're just using a rate to solve what's really a ratios problem. We're going to use the unitary method to do this. So our Camry's listed fuel consumption rate, and this is something you usually see on advertised on TV or in a magazine or something, 7.8 litres per 100 kilometres. How much fuel then could you expect to use on a 65 kilometre journey? Right, so we have 7.8 litres per 100 kilometres. Now the first thing that we want to do is that we want to reduce to a unit. Okay, now we're working with our kilometres, so I want to get from 100 kilometres down to just the 1 kilometre. So to get from 100 to 1, we're going to divide by 100, and I'm going to divide this side by 100 as well. So 1 kilometre, and this will be 0.078 litres per kilometre. Okay, so that's just dividing that one by 100. See, I've moved my decimal place this way twice to get it there. And now that we've got to 1 kilometre, that's the sort of reducing part to one single unit, we're now going to expand it up to the necessary units we want. And according to the question, we're chasing 65 kilometres. So I need to multiply this side here by 65 and multiply this side here by 65, and 0.078 times 65 is 5.07 litres per 65 kilometres. So what we did there was that was reducing to a unit, and this is the expanding to a value. Okay, and then once we've got that, we'll probably want to answer it with words, and we'll have we'll use 5.07 litres on a 65 kilometre journey. Okay. Right, here's another one using unitary method. At a business conference, the ratio of men to women is 3 to 5. If there are 160 women at the conference, how many men are there? Right, so solving ratio using unitary method. So we have men to women. Okay, so remember the order of our ratio is very important. It's sort of talking about that from the start. So we've got some numbers here we can just switch here. We have 3 men for every 5 women. And we're trying to get from 5 to something to 160. What number goes there? So we have to ask ourselves, what happens between here and here? Now, fortunately, this 160 finishes in a 0, which is a multiple of 5. So 160 means it's a multiple of 5. So we just kind of have to figure that out. So one way you could do it, 160 divided by 5 is 32. So we know that this is, hang on, we're using the unitary method for this. Let me show you how to do this with the unitary method. Right, we want to get down to units of women. So this side gets divided by 5. So that means we have to divide this side by 5. So we have 3/5 for every 1. Okay, 3/5 of a man for every 1 of woman. Now, then we need to get up to 160. So 160, so times this by 160, so then we have to times this side by 160, and 3/5 times 160 is 96. So this part was our reducing to 1 unit, and this was our expanding to the necessary units, necessary amount we wanted. So see how we went from every 5 women here to 1 woman, and then multiply out to our 160 that we needed. Now, in class, you got a chance to practice a whole bunch of different types of ratio and rate problems, and using the unitary method is probably the easiest and best way for you to solve these without getting yourselves in any trouble. So I hope you've enjoyed the video, and please maybe have a shot at some of this stuff from the chapter and come along to class with any questions that you have. Thank you.